Good afternoon, teachers. Today we're going to do a lesson on real gross domestic product and how to go from nominal to real GDP. And that's also going to take us into a discussion of price index, the consumer price index, and also real GDP per capita, as well as a brief stop off in how to calculate the rate of inflation. So this is something I gotten a lot of requests to do a video on because this tends to be one of the more math-heavy lessons throughout the AP Macro course. So today we're going to kind of walk through what we're doing, why we're doing it, and we'll include the formulas where necessary. Students do need to know these formulas because they will be asked to calculate real GDP, and they'll need to know what to do with things like market basket price on the AP exam as well. So without further ado, let's go ahead and get started. So in a previous lesson, we learned that nominal GDP, or what we just called GDP, is equal to C plus IG plus G plus XN. So basically, nominal GDP is the sum of consumer spending, business spending, government spending, and foreign spending. And that's GDP through the expenditures approach. What we need to do for this lesson is we need to learn how to adjust those GDPs for changes in the aggregate price level. The reason being because the primary thing that we want to do with GDP is be able to compare productivity in our economy over time. So I want to know if our economy is growing, and in order to do that, I might compare this year's GDP to GDP from 2 or 3 years ago, or 10 years ago, or maybe even last year. The problem that comes up is that we can't really use GDP or nominal GDP to compare overall productivity over time because changes in the aggregate price level, aka inflation, will basically throw off our numbers in some cases by a little bit, and in some cases where we're comparing GDP from a year very far away, it would throw off our numbers completely to the point where it would be more or less entirely useless. So what we need to be able to do is we need to be able to adjust our GDP numbers for inflation. And so when we've adjusted GDP for inflation, that's going to be what we call real gross domestic product. And that's going to be true for other things in this class as well. So anytime we see the word real referring to a real number, that means it's a number specifically that's been adjusted for changes in the aggregate price level. For the most part, we're talking about inflation over time. So the first question we'll get from the students is like, why on earth would I want to do that? The reason being that adjusting for real GDP gives us a kind of apples to apples comparison of productivity across many different years. And so if one of the reasons I care about GDP is I want to know, is the economy growing, I really need to compare real GDP over time to figure out whether the economy is growing, as opposed to nominal GDP, where what looks like growth could actually be the result of changes in the price level and prices going up. In addition to, we just use our GDP to make comparisons and to analyze economic health, finding real GDP is also useful for doing things like determining standard of living, which we'll do at the very end of this lesson, and take a look at things like real GDP per capita, which is going to give us an idea of the overall economic well-being that a country has. And we can use that to compare US GDP per capita to, say, China's GDP per capita, to talk about standard of living across multiple different nations. In order to do that, we really need to solve for real GDP because we want to make an apples-to-apples comparison, and real GDP is essentially going to allow us to do that. So the example I like to use is something super simple. I imagine a scenario where we have an economy where GDP is solely equal to the number of burgers produced. So in our example here at the bottom, we're looking at number of burgers produced in 1940 when the price of a burger was 10 cents. I'm just making that number up. And the number of burgers produced in 2019 where the price of a burger was $1. So presuming that in 1940 we produced 10 burgers and in 2019 we produced 10 burgers, our nominal GDP figure for 1940 would be $1, price times productivity, and in 2019 it would be $10. So if I'm comparing nominal GDP, it's going to look like we were 10 times more productive in 2019 than we were in 1940. And as you can tell looking over here, and based on our previous discussion, that is absolutely incorrect. So this is the reason we need to adjust for real GDP. This is the reason we can't stay with just nominal GDP, because those nominal numbers will give us the wrong impression if there's been a big change in price level between the years that we're trying to compare. If I was trying to compare 2018 to 2019, it might not be that big of a deal, only a 2% or so change in price level. But anything further back than year over year, we really need to solve for real GDP. Otherwise, we're going to get the wrong impression. So in this video, we're going to go over how do we solve for real GDP. Let's get started. So in order to go from nominal GDP to real GDP, unfortunately, it's a little bit of an involved process. So it's a multi-step process here of what we'll need to do to get from one to the other. So the first step in this multi-step process is going to be to solve for what their textbook calls the GDP deflator. For most of this video, I'm probably going to refer to this number as the price index. And the AP exam, sometimes it calls it the deflator, and sometimes the AP exam refers to this as the CPI, or the Consumer Price Index. Although those three things are technically different from each other, for the purposes of AP macro, we can more or less use price index, consumer price index, and the GDP deflator more or less interchangeably. If they get to advanced macro, they'll find out there are some very minor differences between those things. But for the purposes of this class, they don't really need to know what those differences are. I'm going to go ahead and refer to this going forward as price index, but everything I say about price index, or PI, is also true for the GDP deflator, which is what the kids will be used to because that's what their textbook talks about. So step number one, we need to solve for the GDP deflator, aka price index. This is essentially a measurement that'll tell us how much prices have changed from one year to another. So if we're trying to compare our GDP in 1940 to our GDP in 2019, the first thing I need to know is how different were prices in 1940 than they are today, and then I can go forward and make adjustments to our nominal GDP numbers. So price index is essentially going to be a measurement of how much prices have changed over time. The first step to doing that is to solve for this thing called market basket price, or MBP. So the way economists go about solving for price index is we take kind of this giant imaginary shopping cart, and inside that giant imaginary shopping cart, we will put a basket of goods and services. The one that the kids need to know about for the purposes of this exam is the consumer products market basket. So in the consumer market basket, we're going to put one of most of the products the average household uses in a year. So it's going to have a dozen eggs, or a loaf of bread, or a gallon of milk. It's going to have rent included in there and the price of a cell phone. It's going to include, a car and a whole host of other things. And so if we make this list of, thousands of products that the average household uses over the course of a year, we're going to put all those things in this giant imaginary shopping basket, and we're going to check it out through the checkout line and find out what is the price in 2019 of all of these products that are in the shopping basket. Then what I'm going to do, by the way, that number of like what is the price of the basket, this is what's known as market basket price. So that would be your market basket price of 2019. In our formulas, we're going to call it MBP. Then what I'm going to do is I'm going to go back to the other year that I'm looking to solve for. In our example from earlier, we'll say 1940, but it doesn't matter what other year it is. And I'm going to check out the exact same basket of goods and services, but based on what the prices were, in this case, back in 1940, and I'm going to get a different market basket price number. And essentially what we're going to do is we're going to compare what did things cost in 1940 to what did those same products cost in 2019, and that's going to give us an idea of how much the prices have changed on, in this case, consumer goods between the 2 years that we're solving for. Now, one of the things my students like to point out is like, well, we're going to have a cell phone in the market basket in 2019, but not in 1940, or a personal computer. We tend to use goods that are roughly equivalent. So for the purpose of this, yeah, there's going to be some differences between 1940's market basket and today's market basket. Maybe instead of a cell phone, they have landline service, or instead of a computer, they have a typewriter. But given that there's thousands of products in the market basket, a couple of ones being off due to changes in technology isn't substantially going to throw off our overall numbers, so we're not even really going to worry about that. Kids like to focus on the corner cases of things that are different, but for the most part, the majority of the products in the market basket are the same, right? Eggs are still eggs, milk is still milk, etc., etc. So step number one, I'm going to add up all of the prices of all of the goods and services in the market basket for 2019. I'm going to do the same thing for the market basket in 1940, and then I'm going to be able to compare those two things to figure out the GDP deflator, aka the price index. All right, so on our last slide, we talked about solving for the market basket price, or the MBP, between 2 years. The one that the students need to know by name that we're going to solve for here is the one that we previously talked about, where we put all of the different consumer goods into the market basket. So depending on the specific basket of goods and services you put in, you'll get different numbers. Sometimes they'll be slightly off, sometimes they'll be off by a lot. And so when you use those numbers to solve for price index, you'll get different price indices. So the one that we care about is called the consumer price index, which results from putting only commonly used consumer goods into the market basket. If I wanted to put the inputs of production into the market basket, I could get the producer price index, or I could solve for the wholesale price index. We're not going to do that for the purposes of this course. The only one that actually shows up on the AP exam is the consumer price index. So if the kids know that the market basket contains consumer products, and that leads us to a number called CPI, that's pretty much good enough. And the reason that we use CPI is that's going to be the one that we're going to use to solve for inflation a little bit later on in this video. So we're going to solve for the CPI here. Next step, once we've figured out what the market basket price is we need to decide how we're going to go about adjusting prices. And from here, we have a couple of options. It doesn't actually matter which option we choose, but we need to stay consistent. So in our previous slide, we were comparing the market basket of 1940 to the market basket in 2019, and I've got two options here. I can either take the market basket in 2019 and deflate it to what those prices would have been in 1940, therefore taking 2019's GDP and reducing it down to the value of the dollar as it was in 1940, which in 1940 the value of the dollar was actually higher. Or I could take 1940's market basket and I can increase the value of its market basket to be what the value of the dollar was in 2019, where the dollar bought you a lot less in 2019 than it did in 1940. It doesn't actually matter which of these two directions I go. I'm going to get, at the end of the day, an rGDP number that's useful. So usually the AP exam will tell them, normally we inflate old year's GDP to be what it would have been in more modern times, because it's easier for students to understand 1940's GDP in 2019's value of the dollar than it is to understand 2019's GDP in whatever this imaginary value of the dollar was in 1940. But they need to know that we can go both directions. So essentially what we need to do is we need to pick a year, and we're going to adjust all of our numbers to the value of the dollar in that year. In our case, it's either 1940 or 2019. If I want to adjust 1940's GDP to what it would be in 2019, then 2019 is going to become what we call the base year. If I wanted to adjust 2019's GDP to what it would have been in 1940, then 1940 is going to be our base year. It doesn't matter which one you choose, but we do have to pick, and we do have to remain consistent. The formula then for solving for the price index, the CPI, or the GDP deflator, they're all the same here, is market basket price of the year we're looking for divided by market basket price of whatever year we've chosen to use as the base year. And to make this a nice percent, I'm going to multiply that number by 100. So MBP, year you're looking for, divided by MBP of the base year times 100 is going to give us the number for price index, CPI, and the GDP deflator. Just a thing of note, this should be somewhat obvious, but if we are solving for the price index of the base year, I don't actually have to do this because the price index for the base year is always going to be 100. And this means that prices in the base year are 100% of prices in the base year, which should make total sense. So we automatically know base year price index always going to be 100. It's all those other years that we're going to get different numbers from, and we'll talk about what those numbers mean in just a second. All right, so now that I've plugged in our numbers for market basket price from the base year and the year we're solving for, and I've come up with this number called price index, now we need to take a second to understand what exactly price index tells us. And it tells us a couple of important pieces of information. And I like to share this with the students because it allows them to double check their math to make sure that what they're saying as far as their price index number actually makes sense. So the big thing that they need to know is that the price index number, because we multiplied it by 100, is the percentage of the base year's price that your current year, whatever year you're solving for, that their current year's prices are. So for example, if we came up with a price index of 130, that means that our current year's prices are 130% of the base year's prices. Not 130% higher, but 130% of the base year's prices. In this case, meaning that prices from the base year had increased by 30%. An easy shortcut to this is to know that if the price index number they get is greater than 100, that means prices in this year were higher than they were in the base year. And if their price index number is less than 100, then prices in the current year are lower than they were in the base year. So if we got a price index of like 80, that means prices in our current year are 80% of what they were in the base year, meaning prices in the base year were actually higher. Because of algebra, we have another method for finding price index here. Depending on what information the students are given specifically, they may need to use this formula. So in addition to the formula from the previous slide, if students are given nominal GDP numbers and real GDP numbers, they can use those numbers to solve for price index as well. Price index is equal to nominal GDP divided by real GDP times 100. Okay, so at this point we are done with step one. Our primary focus in step one was to come up with that price index, consumer price index, or GDP deflator number. Once we've got that number, we're like 80% of the way there. We just have to do a little bit more math to make that number useful, and we can come up with our GDP. So once we've got our price index number, we've got a couple of formulas we can use depending on exactly which information the students are given. The most commonly used one is going to be real gross domestic product is equal to nominal GDP divided by the price index divided by 100. So because we wanted price index to be a percentage, we multiplied it by 100 in step one, and we're going to have to undo that over here in step two. So that's why we're dividing the price index by 100. Students don't actually need to sit here and like do the division, just move the decimal place over 2 places and they should be good. One thing that I've noticed is my more math-oriented students get irritated by this because they don't want to multiply by 100 in step one and then divide by 100 in step two. And they'll ask if they can go ahead and just skip that step. Absolutely not. Because price index, the correct answer for price index is going to be as a percentage. So if they skip multiplying the number in the previous slide by 100, they're going to get the wrong number. So they might get a price index of 2 when in reality it's supposed to be 200. So even though we're kind of spinning our wheels here a little bit by multiplying and then dividing in subsequent steps, they need to go ahead and do that. Otherwise, they're going to end up A, confusing themselves, and B, potentially getting the wrong answer. We don't want that to happen. So real GDP is equal to nominal GDP divided by the price index divided by 100. With a little bit of algebra, we can figure out nominal GDP from that number as well. So nominal GDP is equal to real GDP multiplied by the price index divided by 100. So at this point, they should be able to reorganize that formula in multiple different ways to end up with real GDP, to end up with nominal GDP, and to reverse engineer it to end up with price index. So if they're given any 2 of those numbers, they should be able to reverse engineer the formula to get the third one. Next, in addition to using your price index number to solve for real GDP, we can also use the price index number to solve for the rate of inflation year over year. This isn't something that they necessarily need to do in this particular part of the unit. So really this part of the unit's focused on real gross domestic product. But I go ahead and introduce them to the formula for inflation here, even though they won't need it for a couple of days, because I don't want to go back and reteach price index in order to get to the inflation rate. So since we've just taught price index, we may as well show them the other thing that they can do with price index once they've solved for it. In this case, that's going to be solving for the inflation rate. So this one's a little more complicated than solving for real GDP. The formula for inflation is going to be price index of year 2 minus price index of year 1 divided by price index of year 1 times 100. And in this case, year 2 is going to be the current year, aka whatever year we're solving for, and year 1 is going to be whatever year we're adjusting from in this particular case. So this will allow me to plug these numbers in and basically get the rate of change in prices over time. Students sometimes want to skip this step and just be like, well, if the price index is 130, then inflation was 30%. That's not actually how that formula works. So they need to use this particular formula to solve for their overall rate of inflation over time. So last but not least, we need to figure out, kind of take a broad strokes from where we started and figure out, once I know how to do all of this math to solve for price index and to solve for GDP and nominal GDP and inflation rates, what the heck is that information actually useful for? As we said at the very beginning, one of the things it's useful for, and the primary reason why we have to learn this, is it allows us to compare real productivity over time, right? I can find out, is our economy actually growing in real terms, as opposed to, is it just prices that's going up? So in our imaginary economy from the first slide that produced 10 burgers, we could see that in real terms, the economy actually wasn't growing because we were producing the same amount of burgers, whereas it looked like we were growing due to increases in the price level. And so to prevent that kind of confusion, that's really the first reason and the most useful reason for finding real gross domestic product. In addition to that, though, I think that we can also get some good information from rGDP about relative standards of living across different economies and across different countries. But in order to do that, we do need to do a little bit of adjustment, and we'll need to solve for not just real GDP, but rather real GDP per capita, because that's going to give us a good idea of, all things equal, what is the relative size of the piece of pie that each individual in that country is responsible for, right? So the United States real GDP versus China's real GDP isn't really a fair fight because there's 3 or 4 times more people in China than there are in the United States. So I'll need to very simply adjust my real GDP number on a per person basis, and that'll give me roughly an idea of what standard of living in that country is going to be. Again, ceteris paribus, so all things equal. There are certainly things like government policies and consolidation of wealth that might throw this off. But assuming all other things about the countries are equal, having a higher real GDP per capita generally is a sign of a developed economy and is generally a sign that your standard of living is going to be relatively high. Having a low level of rGDP per capita is a sign of a developing economy and probably a lower standard of living. So I like to tell the kids, the rising tide carries all ships, right? This idea that if the economy becomes more productive, yes, it's nice that we got a bigger number, but it actually has a tangible impact on their lives. As the more productive we are, the less costly products end up being because of supply and demand, and the better their actual life is going to be on a day-to-day basis. So these numbers matter for reasons other than just I'm making them learn it in an AP macro class. Like, these numbers actually have a tangible impact on their lives. Thank you for watching. I know this video was a little bit long. If you need any assistance, you know where to find me.